Yeah.
Welcome everybody, one and all, to the 8th class of Java Programming, Yo Mama. Hosted by Shiroti.
Yeah. Hey guys, this is a serious doozy chapter.
If you want to find
This is a doozy chapter, guys. Okay, in this chapter we're gonna build a Battleship game. Okay? The way Battleship works is you have a grid. On the grid goes like 3 ships, and you have to try to guess where the ships are and sync.
Not really, it's more like a guessing game, but you just have to correct 3. You just have to guess 3 correct answers.
Well, right now.
Yeah, but this is how it's Okay, in this chapter actually we're only gonna do 1 row. So we're gonna guess on a line from 0 to 6.
They teach you something new here
Besides what?
I don't know, build the code?
It's basically the code you learned before, but we're putting it into practice. There's some minor new stuff, but basically all the code's there.
A big part of the pseudo.
Okay. Okay, so everyone knows how Battleship works?
Yeah. No.
You have a grid?
I never get this game. Never. I don't
Yeah.
know.
The one we do in this chapter is a really simple one. So it's going to be like this.
No, how does the game work?
This is how the game works. So you have... If this thing better work, I'm returning it.
The game recording
Okay. So the game is... Say, we'll just do a quick one over here that's not real. Okay, so say you have 5 spots.
Okay.
I'm trying to read 10 times.
Okay, so we have 0, 1,
Oh.
2, 3, 4, 5. Okay? Yeah?
Okay.
Yeah.
So when you're not looking, say I fill up this one, and this one. Take a guess which one I put it in.
So I need to get
Take a guess.
5.
Okay, so if you guess 5, I'll say miss.
No, you got to put the
Guess
8.
again.
Put the 8.
That's the next part of the game. We're gonna make a whole grid. First,
Oh, I didn't know
this
that.
chapter we do a simple one, really simple, just 1 row. So you hit guess 5, you miss. You guess 3, you hit. So you know that it's always 3 consecutive pieces. You know that's either 3, 4, 5, or 2, 3, 4, or 1, 2, 3.
0.
Can't be 0 because it's only 3 things long. That's how big the ship will be.
What?
There's only 3 spaces that are always together that are done. It's like imagine an ocean where there's a ship.
No, he's saying it could be 0 and 2.
But if you hit 3 and you get a hit, you know that it's either 2, 3, 4, 3, 4, 5, or 1, 2, 3. Right?
Oh,
The ship either goes from here to here, here to here.
Everywhere, it's always like 3.
3 in a row.
This is the game. Like
That's the
3.
game. Yeah.
Some are 2, some are 4, but this one.
Okay, so watch. I'll run the game right now.
There's someone 1.
Okay, so ready? Here's the game. Okay.
So,
Okay, Java game. Enter a number. We're gonna guess now. Let's see. Let's guess at 3.
do the cheat.
Boom, you hit.
Do the cheat.
So 4. Let's do 4.
4. Missed.
So
Okay.
2.
So now you know it's 2, 3. Okay.
1, 2, 3.
Okay. Boom. Okay. You killed it. You killed it.
There's a bug in
Now
the
you took 4
code.
guesses.
Show the bug in the code.
It's a bug in the code we're gonna fix next chapter. That if you go, let's see. Take a guess.
3.
10.
1, 2, 3.
No, 2.
2.
Did it already?
2.
Hit. So I can just do 2 a go. This is a mistake in this game. Is that it lets you do the same one. Next chapter we're gonna go fix that.
So you need to do. Okay. Yeah.
This chapter is just dealing with the basic team. Okay, but that's how the thing goes. Each time it's gonna randomly set the game for you, so you don't know where it is. 1 is a miss, 2 is a hit, right? 3 is a hit, 4 is a hit. Pick 4 guesses.
How come? But in the beginning, 1 it was hit. Now no one
Because
is not.
each time it's changing it.
I pick something else.
Yeah, it's setting up the game for you in a different way, so it's random, so you don't know. Okay, 3 is a miss now. Okay, so you know right now if 3 is a miss, it's very clearly by the end or the beginning. So
Right.
see, 4 is a miss, now you know it's in
So
the beginning.
0, 1, 2.
Okay, so took 5 guesses. That's the game. That's what we're building. Okay, so you're your first Java game. Okay,
Okay.
so this is in the next chapter we're gonna make it more complicated. Where you have actually a grid. So you have to guess A2, which would be over here, or C5 and hit over here. That's how it works in the real Battleship game. Okay. So this actually is very good. Actually, I have to add this to the thing because this is really If you want to be a real good designer, you got to make these as
Yeah, we need to
flowcharts.
learn. I need to learn those stuff.
This is very simple. Flowcharts has 3 things in a flowchart. Okay,
Yeah, how you walk through that.
Circle.
3 things. There you go.
No,
Circle is start or end. That's where you start or end. So you'll go from here, and by the end you'll hit the end, and that'll be the end. So you have start and end.
So this is the beginning when you start doing the program, doing those two?
This is how your program as a whole, your application as a whole
I
works.
know.
It divided into thousands of classes, but this is how the flow of your application works. Okay? Action items are like this. Okay, so say you have, so say you start the game and then you want to go to, okay, so you start and you turn it on and then you go to the store. Okay, so that will say you go to the store. Right?
So
A triangle is a option. Like, for example, do you have money?
Almost like a boolean in a sense.
Yeah. Okay, so then you put a triangle that goes like this. And for the branch out, you branch out where it is. So for example, over here you have money, yes, then do that. And this will say yes over here.
And then can we take that flow chart and move it to to connect to another chart? Saying yes, then go to this chart.
In general, usually a flowchart is for one application. You want to have that's what you want to make work. You don't have a flowchart for one class. Flowchart is for your whole application as a whole, how it works. For example, this flowchart over here will break down into a couple of classes.
Okay.
For example, over here, if you look at my Sublime text, you'll see that we have,
flowchart it's called?
you'll see that we have 3 classes that make up this game. And the flowchart is just one because we're making,
What's simple.com?
we're syncing. This is like a ship. The .com is the ship. That's what they call it over here. You're syncing a .com. I don't know why they did that. It makes it a little harder to.
It is a joke.
Yeah, but it's not a good joke because it's hard to think. You're doing a ship. It's easy to think you're syncing a ship.
Sure.
You know what I mean? Okay, but flowcharts are really good. So you're gonna have to, for when you're making your application,
Is that
Wait.
going to be the next part of homework, by the way?
make your thing.
Yeah.
We'll see. But these you need when making application. You don't need it for each individual class, but you need it for your application as a whole.
Oh, I should say there's still some.com alive. All right, then go back to the beginning. Get user guess.
Yeah. So it's this is really the phase 1 of building application. And if you ever have a client that,
FLU?
what? Flowchart, FLOW. Okay? Don't look it up. Seriously, it's gonna make you Meshuggah for no reason. This is all you need to know. Trust me.
No, it's okay. I want to learn how to build.
I'm telling you, trust me. You're gonna waste your time on that because I'm telling you, flowcharts is like, you know how people are.
Yeah, I know.
Businesses want to do flowcharts. This is all you need to know as a programmer. Flowcharts for like people who do these things for other things, they can go in Meshuggah. But as a programmer, that's all you need to know.
Like that video I
Circle,
sent you?
start, end. Yes. You don't need to be an expert. This is all you need to know. If you start looking this up, you're gonna get lost in a whole other sea. Start and end is a circle. A rectangle, a square, right? Rectangle is an action item. You're doing something, and then the diamond is the decision point. Are you doing? Do you have this? Yes or no? Where you go? Let's walk through this. Okay. So start the game. That would be like hitting Java, right? Java.game, right? That'd be like going like this, right?
From there.
Java game, right? That's how you start. Okay. So the game starts, then you set up the game, right? Game setup. That's where. Look, if we do this,
Oh, when that's
right? It sets it up. It sets the game up where it puts 3 numbers on the row in a random place you don't know. That's setting up the game behind the scenes. That's the first thing that has to happen. Then, now we go into the actual game part. Get user guess, right? So you see over here it's asking for a guess, right? We put in our guess. Let's put in 1. Okay. Put in a 1, which is a miss. So if you look over here, check user guess. Is it a miss or a hit? If it's a miss, go back to get another guess.
Okay.
You see where that arrow is pointing?
Mhm.
So let's go loop. Get another guess. So let's do another guess. 2. Miss again. It goes back again. You see, miss. The arrow goes back. 3. 4 is a hit. So hit 4. Now it's a hit. So now it goes remove that location cell. Okay?
What is it so?
That box.
That thing we're holding. In other words, is 4 is gone now. We killed out 4.
17 bucks.
Okay?
Sort of. Like you can think of it as the box.
So it's at 5. 5 is a hit. Again, it killed it. Now what if it's 6 is a kill? So now what kill does, if I got to kill one, there's actually 3 parts in this decision tree. Miss, hit, or kill. By kill, you remove that whole thing from that ship, the .com, that ship. And later on, we're going to have more ships. So it's going to say, is there more ships they have to kill? Yes, well, then you get more guesses. Right?
Not that it goes to display your score rating.
Right? Up over here, you took 5 guesses, and game over. Okay? So this is a flowchart that describes how your game works. So in other words, these are mainly used, number 1, for yourself, to picture how your application works. And number 2, when you're explaining to people who you're trying to sell the system to, or do it for somebody. Say someone comes to you. A guy came to the show, you're there, he wants me to do an application for him. If I were to sit down with him and want to do the application, the first thing I want from him is a flowchart. I'm going to have to make it for him, but we have to agree on. The specification where you agree with your client or your boss who's telling you what to do, make sure there's a flowchart. A flowchart helps in concrete where programmers and non-programmers understand what the thing is supposed to do. Okay? Cool. So we made the flowchart. That's for the application. Now let's go into each class. Okay?
So if I have an actual application, meaning like an app on a phone, I'm going to have a million applications, right?
What do you mean? One app on your phone usually has the flowchart. You'd be
Right,
surprised. You
just one
start,
flowchart, the whole thing?
usually, if you start an application, you might be able to do a lot of stuff. But when you press open an application, everything you do from there on is just decision trees. It can be a huge flowchart.
That's my point. It's going to be huge.
Yeah, huge. And you can break it into different parts. You want to be smart, you know what I mean?
That's what I'm saying. I would think it was a couple flowcharts so that the other person would understand.
Yeah, I mean, but again, don't start learning flowchart books. This is all you need to know.
Oh, that's all I know.
Yeah, this is really all you need to know.
It's our language to talk to non-programmers.
Yeah. And to yourself to clear it out in your head how it's supposed to work. Okay. Okay. So remember, now we have this over here says that what the program needs to do, right? Now, what's the problem with to do? To do, when you hear the word do, that reminds you of like SQL, SQL, where you're doing things not in object-oriented programming. In object-oriented programming, we have to think of objects,
Right.
what they do to themselves. Right? There's a ship, and it checks if it got shot. If it gets shot, it drowns. That's what the ship does. That's the ship object. You have the game that creates a ship. You know, you have. So that's really the thing. When you're thinking of for the flowchart, you got to be careful not to go into procedural programming, go into object-oriented programming. Okay. Okay, so here we go. This is how you develop a class. Okay? Remember, this is developing a class. When you make an application of first type of flowchart, then go to these 6 stages of making a class. Okay? This is so important. This is going to be, you know, if you keep to these rules, you'll have a very successful career.
What, those 6 rules?
These 6 rules. Okay? Many programmers don't, and they are horrible programmers, and they never build up anything. Okay?
So, we'll go through them or not?
Yeah, we're going to now.
Figure out what
I just need to be sure I get away. Okay.
Why did you write the pseudocode for the
Okay, so the first thing is figure out what the class is supposed to do. This is over here. This is
Okay.
First, figure out what the class is supposed to do. Right? List the instant variables and the methods. In other words, make the UML diagram. Right? UML diagram is this simple thing. We have the class name and then the methods, the instant variables and the methods. This picture in your head what each one's going to look like. For example, simple.com, which is like the ship, has where the location cells are.
Did they have to call it check yourself?
I know.
Check yourself.
Okay? It has the thing of number of hits, how many times it was hit. Imagine a ship on the sea, you know, it has a thing. We're hit 3 times. Okay? And
methods.
And location cells would be like where in the ocean are we located, like the GPS. Then the methods over here, check yourself. That's when, you know, if it got shot, does it check if it really got hit or not? Did it hit the water or hit us? And then set locations, that's, you know, we're going to decide where we are. We're going to make position where we are in the ocean. So set locations, when we're going to decide we're 1, 2, 3.
Make it random?
Well, we are, because we're going to make a random numbers and then put it in the method to set it to those random places.
What has it dot math? Random
Yeah,
math?
we'll do something like that, yeah.
Okay.
Okay, so this is the first step. I just put 1 over here, but you're going to have to make for each of the classes that you're building for this game a UML diagram. UML is a simple thing. All it is a square box with the methods and instant variables. Okay? Step number 2, write the pseudocode. Pseudocode is just test code. That's all it is. Oh, sorry, take it back. Pseudocode is not test code. Pseudocode is fake code, but it's like almost there. Like you're trying to get in your head somewhat of imagining what it should look like. Okay? Pseudocode is very important.
Draft.
What?
Like a rough draft.
Rough draft, exactly that it is. And you don't care.
You know it's not going to work.
Right. You don't even care about syntax. Don't care about syntax at all. In fact, sometimes it's better not to do it inside a JavaScript because you start making all these errors and start making you dizzy. Just put it on a regular notepad on your thing because otherwise you're going to hear, just do a quick draft of what's going to happen. For example, over here, let's look at this one for thesimple.com, which is the ship, right? Here's the pseudocode. This is not real code. You can't compile this. This is just, so we're going to do declare an int array. Remember, an array is something that holds a couple spots. That holds location cells. We'll call it location cells. Declare an integer, tell the number of hits. We'll call this number of hits, and we'll set it to 0. Right? When you first get the shit, it was never hit. Then we'll declare a method called check yourself. Right? Pull down your panes and
Check yourself before you wreck yourself.
Okay, check yourself. Right? It takes a string. We'll see why later. Why we're using a string? Why not a number? Right? We'll see that soon. And it checks to see if that's where it got hit, and it returns a string that says hit, miss, or kill.
But we know that we're going to do A1 or A2. Is that why it's two string?
That's one reason. That is a very good reason. But in the first game, we're not going to have that. So why we need it now is more because we'll see soon. The command line when a person enters over here
is always string.
Right. When I go 1, this is a string no matter what because it's coming from over here where I can enter anything.
Right.
So you have to take it as a string. Okay. This wouldn't be the case when we make a GUI later on, where you can force the guy to make something, Okay, so this is our first thing, and then set locations is this setter method, right?
Yeah. Takes
an integer array, which has 3 cell locations, like 2, 3, 4, and places it. So we can first, before we call this, take a random math thing and make 3 numbers, right, and then pop it into location cells. Okay. Then let's do the pseudocode for the methods. Here's the pseudocode for the check yourself method, right? So imagine like you're a ship, you're the commander of the ship, and you see this missile flying, and you hear like a splash. You don't know if it hit the boat or hit the ocean. So you check yourself. Was our ship hit anywhere, right? So first thing is you get the user guess parameter, right? He entered 2. Let's get that. Let's convert it to an integer.
Here's the question: why, if we already do the string?
Well, our array is 1, 2, 3, making it as an integer.
Right, but why is it there? So how would you go back to that?
Can you say again?
If you check yourself method is a string.
Right. In here, we're converting it to an integer. We haven't discussed converting it.
Okay. And then we can go back and reconvert it.
If we want to, yeah.
Right, okay.
We're returning it. We're returning a string, but right now we have to test if the integer matches any of an array. We'll see soon how to convert it. So we convert it to an integer.
Equal kind of thing.
It's similar like that. We'll take there's an integer or class, and we'll do parse it, basically check if this is an integer. Okay. I'll show you here very quickly. If I look over here. Here you go. See over here, integer parse int. This is what you have to do. Integer.parse int, and in there you put whatever you want to check. They'll check if that's an integer or not. If it's not, it'll blow up.
Right, but all that would have to change once we do A1, A2, right?
You're probably right. We'll see. Let's focus on this chapter. When we get to the next chapter, we'll go to the next one.
Okay.
That's a good question. Very good question.
Did you repeat that about parse indicators?
There's, if you want to parse, if you want to check, parse basically means do this, see if it works, right?
Right.
We take integer. This is a class. You see, it's like uppercase. Dot parse int, and in here you put whatever you want. This is what we're passing in.
Okay.
So you can put in there 5, and it'll take 5 with quotes and take it out and put it into an integer variable. Now 5, right? It's putting it into this guess, which is an integer.
Okay.
If you put in there a b, it'll fail. For example, look over here. See, I can do Here's the game. If I put in 1, it works fine. If I put in F,
Oh, yeah.
boom, it explodes. Okay, this is not good. We should later on we'll learn about exceptions so you can catch these errors and tell the user, hey, enter the right thing. But for now, let's just let it explode. Okay, so this check yourself, this is really the main part of the ship. That's the main thing. Deciding where you are in the ocean, that's easy enough, you know. But the main thing is checking yourself. So we're gonna do over here. First, get the string guess, convert to an integer. Now let's check if that integer the person guessed is in any one of our integers. So you run through your loop. Okay? So for each location in the int, right? So you have 2, 3, 4. Let's check. If the user guess matches, increment the number of hits. What?
Okay.
Okay. So if the user guess matches, say he entered 1, right? Let's go over here. Let's do a game again. Say enter 1. Again, it was a hit. So look over here. 1. If the user guess matches, increment the number of hits. Now I got 1. I got 1 hit. Remember, I've got 3 hits. The ship is gone. Okay. If the number of hits is 3, return kill. Right. For example, if I go like this, which is actually an error in the system because it shouldn't do that. But oops. See, on the third one, it recognized I hit the ship 3 times and it says kill. Okay, so if it was hit 3 times, it returned kill. Otherwise, it was not a kill, and therefore we're just return hit. Okay. Or if none of these happen, if there was no match, right? See this if there's a message, if it doesn't match, then return back miss. Okay, so in this loop, we're going to loop through the integers, and there's going to be 2 if statements. For example, let's go through like a little paint so you look at this very easily. Okay, so say we have this thing like this, and we have the buckets. Okay, oops. Okay, and say we have it over here. We have it in this position. So it's 0, 1, 2, 3, 4. Okay, say he guesses 1, right? That's a miss. What if he guesses now on the next loop he guesses 2? Okay, so that's a hit, and now he got 1 hit. So we'll remember this. We have the instance variable called number of hits. Number of hits now goes to 1. Okay, say he enters 5. Well, that was a miss. He enters 3, another hit. Number of hits go to 2. He enters 4, number of hits go to 3, and therefore it's a kill. And the ship sinks.
So
okay?
would we have to, if we, oh no, never mind. We'll go to the next one. Okay. I'm jumping in.
Okay, so, and then that's it. That's it for the check yourself. That's the most complicated part of the game, really, is when you're taking a guess. Did you hit the ship? No, yes, or no, did you get a kill? Okay, and then the easy method is just to set the location. Over here, we take the integer array that we're deciding to put it, and we make that vertical. It's like taking. It's like
a massive thing. That thing looks like a pimple-ish thing.
So, right, this is like almost like a GPS. It's like someone going to your machine without you looking and saying, go to Hong Kong, and you don't know where you're going. So that's, we're gonna put a random number in here for the ship to go to. Therefore, you can't know where it's going. Okay. Okay, that's it. That's step 2. So step 1 was write the UML. Step 2, make the pseudocode. Step 3 is make the test code. Okay. Test code is a bit confusing when you think about it at first. But test code is a real code, real Java code, before the class is even created. Okay, and I see why. So, for example, in this thing, there's only one I made for this one. We should make it for let's do it for this one. The main thing this one we want to test something of the ship. Okay, so if we had a ship, how can we make sure the ship is working right before I have a full-blown game? Let's test the ship is working right. Right. So look over here. Here's a simple .com tester. Right. We're going to make a simple .com. We're going to set its locations. We're going to do a user guess and see if the user guess worked. Right? Yes or no? For example, look what happens when I run it.
This kind of what QA does?
No, this is you gotta do. So you got it was a hit. So remember it's working fine because it should say hit. Because I put in 2, 3, 4 and I entered 2. Okay? But this you create before anything else. You say, how's that possible? It won't compile, right? I can't do simple.com over here if there's no simple.com class yet. The reason why I do this first is this when you're testing out a test script, it actually helps you, number one, picture how other programmers are going to interact with your class, or your game is going to interact with your class, right? You can be making a new ship, setting the locations. So you make sure the stuff works fine. Therefore, the second you're done with this, boom, you can run your test to make sure your test works.
But how are you going to know your test is correct?
You won't well, this, look, 2, 3, 4,
Right.
and I put in 2, I better get back this, and I know it worked.
Well, I'll only know that works once in the code.
That's right. But if I make the code and I run this and I don't get back hit, I know something's wrong. That this is wrong.
I see.
Okay.
Instead of you running through every single one of those other programs.
Right. Instead of making your whole game.
Massive thing first,
Right.
make a small, tiny version of it.
Yeah. So the reason there. Let's read this. Okay. The act of thinking through and writing the test code helps clarify your thoughts about what the method itself needs to do. As soon as your implementation code is done, in other words, the real code is done, you already have test code just waiting to validate it. Okay? And here's the most important line. Besides, you know if you don't do it now, you'll never do it. And that's really true. If you don't test code the first thing, you'll never write test code. And therefore, what happens now? Watch this. Over here, I know this works fine. Right? When I run this, it works fine. What happens now if I make a change to the game? Right? Well, this should still work. This is the basic idea of the game. This should still work. But if I run this and the change I made breaks this, you know that something's wrong. So in general, this is the way it works with code. You make a change to your code. You run all the tests before you release it to the client. So same like a thing. You have all these testing classes that test your code out that make sure any change you didn't break any of the first things that are supposed to work fine. This is supposed to work fine. So whether I go over here and do some other change, whatever it is, this should work fine. If it doesn't, then either this is wrong, the change is made, or I got to update the tests. Okay? The tests are a good way to test out your system parts right away off the bat without having you go to the client and for them to find this error for you. Okay? And this is a simple one. In real life, testing scripts can be, you can have 100 of them on a complicated application. If you go to WhatsApp and they make a change to WhatsApp, they have, what is it, I don't know, 500 million users. They better make sure that thing works fine. They can't go bring out the users, hey, I tested it out now. They have to have scripts that are testing it now, and any change, they run those scripts again. Make sure the general function doesn't break.
Yeah, but that's why you also have beta testers after that, because you don't know.
Beta testers are good too. You need those as well. But first of all, you don't want to waste beta testers' time. Beta testers take time too. For example, if I had this test and I would have gotten the error 1 second.
Right, some companies don't like give it to like a special company. Some companies will actually release it, like Facebook, for example. I know for a fact because my friend had it. Facebook, they're redesigning everything. They actually gave to like random phones.
No, I understand that, but you don't want to give them something that you could have gotten off the bat as a mistake.
Right.
These tests help you catch things off the bat. For example, when I was working for a certain company, they had a whole team in India that was doing testing for us. And at first, our programmers were being lazy about making these test scripts. And what would happen is they'd find, on a simple application, 300 bugs. So then they changed the rule that every single class has to have test scripts. That dropped. So you still went to QA in India. They still ran through our code and not through as programmers, but actually running the game and making things work. And they found, a tenth of the code of mistakes. Because we had scripts that test the whole entire system out in different ways. Put in a 3, put in a 4, make it this way, make it that way. And you just run it. It takes 1 second to run after you have it there. Okay? So you write the test code first. This is actually the first thing you'll write. Even though you can't compile it yet. You're going to go ahead and compile this and then run this. This is the first thing you write. Okay,
and then you write the game helper in the game?
So
You
no,
can't
when you write this,
compile that yet, right?
you can't compile it, no. So say we have, so let's run through it. Don't look at the other tabs. All we have now is a tester. So we're going to test out a ship without doing the game. Remember, just the ship itself. Not doing the game. Here's a ship. Making a new ship. Set the location to these cells, 2, 3, 4. right? So ship, set locations, in other words, go to this spot. Then let's take a user guess, let's make it 2, and let's check it. And it should be hit.
So check yourself, obviously check yourself somewhere else.
Haven't created yet. Remember,
I'm saying.
that is this we just discussed.
Alright, no,
Wait, doesn't you set to write down, you set to do simple.com and then also simple.com tester.
No, this goes first. Tester goes first.
So then why do you have check yourself then?
That's his whole point. His whole point.
Yeah, exactly. That's the point of this, that you are writing your code that you can't compile yet. But the second that you go ahead and do this,
Oh.
boom,
Think
you
about
run your
this for a
test.
second. Think about how God created the world. You know what I'm saying? He first put all the testers, and then the last thing he did was put humans. And then he added a little bug, so he started again.
Okay, so there's 2 reasons why I do it first. Number 1, I do it first. Look at this. While I'm doing this, I don't have to make this whole thing. Man, look at this. When you look at this code, I can clearly see, boom, I'm making a new ship. I'm saying the locations, even though the stuff doesn't make sense yet because it can't compile. But once I do this, this should compile fine.
Yeah.
Okay? And you should run it. In other words, I can test a ship right now.
You're not really gonna test it until you make that simple.com.
But you have it ready the second it's done.
Oh yeah.
But the thing is, if you don't do it now, if you spent the 2 hours making this, you go, oh man, I'm tired. You're not gonna start sitting down and do this.
Right.
There's no way.
Once
I'm
you have
telling
the
you.
test already, that's a simple thing to do, and then you make the.
And I did that, but
beat.
it actually helps you clarify how the system works. I have to make a ship. I have to set
So
locations.
it's sort of like cooking, like frying a meat. First you'll saute the onions and the vegetables, and then you'll put on the big piece of meat.
Sure, yeah.
You don't cook.
Okay, guys, we're running out of time. So
It takes an hour to do this out there, this stuff.
okay, so
Well, it's cooking.
I don't know.
okay, so that's it, guys. That's the next step is the real code. Okay, next step is write the real code. So you're gonna write this real thing. Okay, that's the step 4. Step 5 is then go ahead back and run your tester and debug and re-implement. Right? If you find bugs, then you have to re-implement. Like, for example, we found one bug already where I can go.
Oh, you're ready, man.
I can do 4 times in a row, and that shouldn't make any sense. So there's a bug in the system, so we're gonna have to re-implement it.
So maybe this is gonna be an homework.
How to fix it? Well, we're not even on the chapter yet.
talks about it. That's the thing.
Yeah, the book on purpose does it, so you can.
So easy a kid and I can do a memo.
Okay, so guys, that's the 6 steps. First step, as a whole, make the application flowchart. Then, for your class itself, number 1, make your UML. Number 2, make the pseudocode. Number 3, make the test code. 4, the real code. And then from there, go ahead and go 5, run your testers. And then 6, do it again. You have to start going, through this whole thing. Okay? And it is 6 o'clock. So we're going to stop for now. And tomorrow, we're going to actually start looking through the code. You'd be surprised. We just went through basically the entire chapter 5. That was basically all chapter 5. Tomorrow should be quick.
Okay, so what did you think I did wrong, by the way? If you had time.
Let me just send you these 4 scripts.
Okay. Through email?
What?
Through email?
Yeah.